our program simplePIC.c simply flashes the two LEDs, LED 1 and LED 2, on and off, unless you press the user button, which pauses the flashing. So what we want to do now is look at our program and figure out why it has this behavior. So here, the first thing we do is we include a header file for the library called plib that we'll learn more about later. Then we have a function prototype for delay, which we'll see down here. And then we have the main function. And all the main function does is it sets 4 variables here, 3 of them using decimal representation, 1 of them using hexadecimal. And then we enter this while loop, and we have while 1, so it's an infinite loop. Then we start by doing the delay, and then we simply change the value of this variable lat_a_inv. And that's it. That's all the program does. If you look down here at delay, the delay enters a for loop that it goes through 1,000,000 times. And each time it goes through that for loop, it does this while check. And it's saying if port D bits here evaluates to false, then you have the not in front of it. That's the exclamation point. So you have not false is true. So if this evaluates to true, it stays stuck there in the while loop. And that actually corresponds to while you're pressing the user button. So if you're pressing the user button, port D bits RD13 evaluates the false, so this expression here evaluates the true. You stay stuck in the while loop until you release the button. Then you go back through the for loop, and once you've done it 1,000,000 times, then you come back up here and change the value of lat_a_inv. Okay, so that's all the program does, very simple. The only thing that makes it interesting is that all of these variables, which you can see we'd never defined, we just started using, all of these variables correspond to special function registers on the PIC32. So to understand what this program does, we can take a look at the data sheet for the PIC32. And we can see here that under the digital input-output section of the data sheet, it tells us what tris does and lat and port. And you can see these are the variables we have over here. We have tris_a, lat_a, and port D. And it turns out that tris, or tri-state, tells us whether that digital input or output is going to be an input or an output. Lat is used for writing a value, so a 0 or 1 to a digital output. And port is used to read an input from a digital input. So now we know that lat here is controlling a digital output, port here is reading a digital input, and tris is setting the direction of the pins to be input or output. We can also consult the memory organization section of the data sheet. And here we can see the actual virtual addresses of tris_a, port A, lat_a. And you can also see which bits are defined. So for instance, tris_a here has a bit called tris_a15, has a bit called tris_a14. And similarly, lat_a has a bit called lat_a15 and lat_a14. And in our program, we used lat_a4 and lat_a5 bits. And we also used port D bits RD13. So between using the data sheets section on digital inputs and outputs and also this memory organization section of the data sheet, we can start to understand what these commands are doing. Now, on our Nu32 board, the lat_a 4 and 5 pins are connected to our LEDs through a circuit that looks like this. And this is, say, RA4. And this corresponds to LED1. And what this says is if RA4 is high, if it has a value of 3.3 volts, the LED is going to be off. If RA4 is low, then current is going to flow through this resistor and diode, and we're going to get light from LED1. LED2 is exactly the same, except it uses RA5. And then finally, pin RD13 that corresponds to the digital input that we're checking down here is connected like this on the Nu32. Okay. So this is the user button. So if you're not pressing the user button, RD13 is going to read high. If you are pressing the user button, this switch closes, then this point drops to 0 volts. RD13 is going to be reading low. So that's how these special function registers interact with the user button and the LEDs on the Nu32. What we haven't seen yet, though, is why were we allowed to start using these variables like tris-A and lat-A bits when we never have them defined or declared anywhere in this program? And the answer is because we included plib.h up here. That includes declarations of these variables and actually is going to give us access to the addresses where they live, the virtual memory addresses where they live on the PIC32. And this is something that we'll look at next.